Right. Hi everyone. How are you doing? I trust that you're doing fine. My name is Ian alias your Java guy, and in this video, we are going to see how Java 25 plus versions are making life easy for people who are starting to learn Java, at least in this era. So, for them that have been there for some time, let me reduce this guy. Yeah, that's okay. You've definitely come across this monster here, and this monster is a public static void main taking string args, and then you for you to print a simple S out, you need to write all these things here. For you to write a simple SOUT. How is Java 25? Oh, before you even get to Java 25, look at how Python was easy for people to be onboarded in the language. So if you want to print hello world, which is the genesis of the life of every programmer, unless you started differently, is normally a hello world. And in Python, you just do a print hello world. But in Java, you had to go through this miraculous way of writing stuff for you to get a simple output as hello world. If you compare the two, one of them is verbose, or so to say, is very wordy. So how is Java 25 making life easy for developers? So I'll be using this platform, learn.java. So if uh, you're trying to experiment with the language, so they have a very nice place here where you can experiment with a few lines of code. Yeah, so you can just do io.println, and then you have your hello, whatever message that you want to pass there. So let me just create a simple project on IntelliJ. So I'll just come here, project, yeah, Java, and then just call it Java 25. I don't need a build tool, so I'll just choose the IntelliJ as the build system. I'll use Java 25, and then I'll create the project here. Then after that, as it loads, yeah, let it load. Okay, cool. That was fast. Fantastic. And now we can see. So we have, you just create a simple file. So it's called a compact file. And then after you do that, all you just need to do is just run the code that is already given here. But ideally, this is how the code looks like. So the issue, yeah, you need to use Java 25. Yeah, that's okay. So we have this pre-written code here, which I'll delete. I'll just delete this pre-written code in the comments. I'll also delete this here. Thank you so much for the picture. So this is how you do it. So if you're not familiar, you just come to the source, come here, create new Java compact file. And with that compact file, you don't need a class. Even if you select a class, you can still see here compact source file. Uh, and then it's called main, and then inside that we have this here. So how do we print a simple main? So this main is what we had like public static void main. So first, we don't have the class definition here, and we are doing away with the arguments that we were passing. Of course, you can have them there, but if you don't need them, I don't see the need for creating it. So I'll just do an io.println, sorry, io.println, and then I have hello world done for me there. And then if I run it, you'll get to see that yeah, this is why I didn't run. I don't know why. But it's normally in demos, things normally plan. Yeah, you get a simple hello world. Yeah, that's it. Then now how, like any other programming languages, we have variables, data types, and whatnot. So we how do we describe numerals? So with numerals, we of course have different data types. We have primitive and non-primitive data types, which are references or objects. So for the primitive, we have a way of representing numerical figures. We have for numerical, we have whole numbers or digits, and then we also have floating points, which represent decimals. So if you want to represent a whole number, you just say int something like a num equals to 10, like that. And then there's another way of printing. So you can statically import the print line. So print line, you can just say print line like this, and then you print the number there. Good. So if I statically import that, there's a static import to java.lang.io.println. So if you go under the hood for this, you'll just see there's nothing very miraculous that has happened. It's just like a wrapper for S out. So the JDK, they're handling that for you, so you don't need to write the S out. But when you do the print line or the IO, because it's from the IO class, okay, they have a private constructor here, but it's coming from the IO class. So if you do IO.println, you're just calling a system.out.println under the hood. So they are trying to abstract that for us. The same applies if you want to, of course, there are other ways you could represent numerals. We have short, we have byte, and then short, and then int, and then long. Those are various data types. So you can have long, and then I just have it as num2 equals to something that's a very long number, for example. Numbers that surpass the int, you'd have them stored as a long. So you can have the L here to show that it's a long, and then you can also like print it out as well, so that you get to see what normally happens there. You can just say num2. The same case applies when you need a short. So you just say a short num3 equals to short, and we have these data types because they represent a specific range. So this I guess should be 28. I'm not sure this if it it can hold that number. If I had another number, it can't hold that, it can't. So there is normally a range for this, which I can't remember at the top of my head. The same applies for floating points. So we just have a float, and then you can just float num equals to, you can say 89.90, something of the sort. You also need an F to specify that it's a float, and then you can also print it out, which I'll not do it now, but you can print it out and then you get the value. The same applies to a double. So I think double is it's sort of like the default floating point number. Double float equals to something like, so for double you don't have to specify that it's a double, so it automatically knows. There's this keyword that came in Java 10. It's called var. So var is a way of ensuring, okay, it can infer the type during or when you run it, okay, or depending on the object that has been created. So we can say, before var, we can say something like a string. So this is another data type. Now this is not a primitive. This is a non-primitive. It's an object. It's a reference type. You can say here something like Java guy, like that, and then you can also like print it out, print line, you print the name, and then of course you'll get that what is printed. Some reason, okay. Yeah. So if I print it out, you'll get to see that the name is actually printed there. And then so instead of saying, so you possibly have seen some other languages. So you can see Java, you've seen some other languages that do they have the thing called type inference. So you can say var, or JavaScript says var or val. So we can say var name2 equals to Java guy2, like that. And then so the type is this is what determines like what data type is stored here. So you don't have to explicitly define the data type for these objects, and then it will be inferred automatically. So that is type inference. Let me see. Oh, we also have a way of representing conditions. So you can have booleans. So a boolean is a primitive. So you can just say boolean is true, like that, equals to true, and then you can print out the value. We also have character. Thank you so much to complete. Character is just like a way of representing a symbol. So, and then the difference is they have this, they're enclosed between this. The other data type for int that I had mentioned, so let me just ensure I cover almost everything, is byte. Let me just say small equals to. So byte ranges from 127, positive 127 to negative 128, if I'm not wrong. So I'll just hyphen 8, So byte is a representation, so the smallest numerical data type. And that's ideally it for data types. You can do a bunch of things with strings. You can concatenate. You can do all those things, but ideally that's how you play around with these things. So the other thing is conditionals. So you understand when you want to your code to execute when certain conditions are met. So you can also have conditional. So this one hasn't changed, so it's just similar to how it was written. So you can have something like an int age equals to 90, and then you say if the age is less than 18, like that, you are supposed to print you're not old enough to vote, and then else. So this just remain as is. Else um you okay, I'll just say print line like that, you're old enough to. So this here depends on the kind of condition that has been done. So this is just like a normal condition. You can also have if else if, but that's not the reason why we are here. The other bit that I'd love to talk about is the modern switch expression. So you've seen if you're having, say for example, an if else if, say let's say this is a string, um okay, string day, okay, string day equals to not even string, so let me just say int day equals to say 5, and then you have if day if day equals to, I hope you now get what you're getting sense of what I'm trying to say. Here you can just say something like Monday, like that. You can say else if day equals to 2, we change this output here. We just say it's a Tuesday, yeah, like that. You add another else if like that. No, sorry. Else if day equals to 3, we can print line, just say I hope it will do it for me, then say it's a Wednesday. And then I'll not cover all the cases, so you can have the last one, which is an else. If none of them happens, so we just print line and say invalid, like that. So that's an if else if. Okay. We can change this, we can better this nested using a switch. So instead of this, we just switch through the day, like that. And then we have cases now. So there are various ways of writing cases. So you can have this case 1, I'll just autocomplete. So there's this case, and then the value, so the day. So if it's case 1, print that and then break, and then 2 break, like that, which is a lot of work. So there's the other way of writing switch. So if it's case 1 like that, we just print line, and then say this is today, it's Monday. So this one automatically handles the break for you. So this is the new way of doing switch. So the same applies to that, and then as always, you have the default which it tells you. So for this case, we'll get an invalid because we've not covered that scenario. So that means that we don't need all this, so the switch can do that for you. At the same time, you might want to assign the value of that you get from this switch to a value. So this is a okay, this for this case, it's printing stuff. So we can change this to do we say return really? No, I guess we can just say here string day of week equals to that, and then here yeah, we're just supposed to return string version. Okay, so I'll just say here, okay, I'll remove this. Oh boy. Yeah, so you can just do away with that, like that, and then yeah, you just do the same for these ones. Yeah, like that, and then you can reassign. So you can print line the day of the week there. So this is when you want to reassign. So this is a switch expression. Trying to see if there's anything else I'm missing. I don't think so. So that's ideally for the switch expressions. and you can do a bunch of things with them as well. So the other bit is how there is a concept of OOP. Okay, so we've already talked about variables. Forgot to mention this. This is an initialization. This is an initialization. So you declare and assign at the same line, but this is a declaration. So this is a declaration. This is an initialization. Initialization is when you use the assignment operator to assign the value. Okay. We also have ways of looping through data. So you can just say for int I equals to 0. So this is a for loop. I less than or equal to 10, like that. And then we can just say here print line, or let's say print line, like that. We can just print the I itself. So this would print 0 to 9. So this is a for loop. We also have other types of loops, which is while loop and do while loop, which is not like in the scope of what we want to do, but we can do them. So we can just say do. Do executes at least once. So you can say do print hello world. We want to print hello world 5 times. So we say while need here and count, like that. Here I need to say count plus plus, and then here I can just say while count is less than or equal to 5. So I need to initialize it here, and then it starts from 1. So that's how you print, say for example, hello world 5. You can print hello world 5 and like 5 times as well using this one, so that it's relatable. So less than or equal to 5, like that. Just have 1 here, then just say hello. Yeah, that's the do while version of this while loop. You can use a while loop as well. So you can just say while, and then we can use another count. So we can just call it this int counter equals to 1, like that, and then you just say while counter. Yeah, this is not gonna be right though. While counter is less than or equal to 5, so we just start from 5, like that. No, while counter is greater than or equal to 1, 5, it will keep on printing. Yeah, so this is a pyramid scheme. Okay, let's see. So we just say print line. So we will fix it. We'll fix the logic in just a moment. Just say print line hello world, and then let's see. Okay, counter. So we need to say counter. Counter. I've already seen the issue. Counter plus plus, and then here just say 1. Yep. So the counter starts from 1, and then we're saying while counter is less than or equal to 5, we print hello world, and then we print the counter. So that's ideally it. Yeah, and that's as easy as the basic things in Java could be. The other bit now that is quite important is now, say for example, OOP. So I'll just have here what we call OOP. So OOP is object-oriented programming. So here we're representing, how do we represent data? You're building a student management application. You need to represent your student. So you need to represent your student in a packaged way. So okay, so the paradigm that we use here is object-oriented programming. So we are positioning our application around the concept of object. That's why it's called object-oriented programming. So the orientation of how we build software in this paradigm is based on objects. And then you'll come across terms like objects, classes, and then a bunch of other things. So the basis of all this is say classes, and then you give birth to objects. And then this, now when talking about these two, there are a bunch of other things that will come across. So this brings to us to the pillars of OOP, and then we have something like, let's just start from the basic one. What you get in a class: encapsulation. We have inheritance, and then we have, after inheritance, we have polymorphism. sorry, polymorphism, we have abstraction. Yeah, and then in abstraction here, we'll talk about interfaces and abstract classes. Yeah, so those are the key things that you'll encounter when talking about OP. So you start from classes. So what is a class? A class is a blueprint for creating objects. So it defines the skeleton of how our object should look like. So if I say that I'm building a student management system, I need a student. So what will a student contain? So what are the data and methods that this student can contain? So that's what we are referring to here. So just a second. So that is what we are referring to in this case. Like for example, we can have a class. So a class has the following. So a class has the following. A class has other people will call it fields. Others would call them attributes. Attributes, and then we have methods. So we have the data, and then we have ways of manipulating the data. So that's ideally what the class has. We can also look at this documentation here. I remember I said I'll be using this to write the code. But we have a section here. Okay. We should have a section here. Learn that has this definition. So a bit of work. And here, I'm just looking for the term class. So back then, when you're starting to like learn Java, you needed to understand what a class and an object is. But when you're starting now, you don't need to understand what those are. Okay, when you're learning about data types and all those things, you don't need to understand what a class is. So I wish there was a way I could search. So let's see if this map would, it doesn't give us anything. Home, 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 please. Yeah, learn.java, learn, and then yeah, table of contents. I'm looking for classes. Okay. Yeah, classes. Yeah, so we see we have what is a class? Where are they defining? A class is a blueprint for creating objects. The classes define the data and behavior. So we have the data, those attributes there. And then now an object is now an instance. So this is how a class would look like. Like for example, they're giving the example of a dice. So dice contains the number of sides, and then the behavior is get the number of sides, set the number of sides, and then the method to roll the dice. So that's ideally how you kind of talk about classes. Let's create a simple class here. So I'll just say class. Let me just call it, say, the example I was giving. So that is how you create a simple class, and then you need the fields and attributes. So you can just say string name like that, and then you can also say string reg number. You can also have an int here as the ID. So there are a bunch of things that we're not talking about here. So this is a class. So these are the attributes, and then you also have now the methods. So these are attributes, and then here we have the. So methods is like, for example, we have how to say get the name of a student. So we just create a method. I've remembered something. We've not okay, let me just use this one. This one, and then we just want to print. So we'll just have that there. So methods are pieces of code that can be reused across the program. So let's like find a Google definition of methods. That is just like reusable pieces of code. Yeah, a block of code that is designed to perform a specific task. So you want to print the age, you want to print, yeah, just like a reusable piece of code. So you don't need to do things over and over. So this is a method that can help us print the details. So this is what a class is. It just like defines the attributes and methods of a specific thing. So it's a blueprint for creating objects. That's the definition that is given. And then how now do we what is an object now? Sorry, because objects are derived. So now an actual instance. So this is an instance of a class. So that's an object. So that's an instance of a class. This is what we refer to as an object. So I can create here in the main method. I can come say I create student and then call him student equals to new student, that like that, and then I can access the method. I can just say student student. We have the dot operator, so when you click on dot, you can see I can access the ID, name, and reg number, which is not good practice. I'm just interested with the method. And then if I run, if for example I run this code, I'll just need to, because I'm already done with this, I can just delete or comment. So just control, then I comment. So if I run this, you'll see that we get the details of the students. We have 0, null, and null. We have that because we've not assigned the values. So we are getting 0 and null because we have the default values that a specific data type would be storing. So if it's a primitive like int, it stores a 0. If it's a double, it stores a 0.0. And if it's a string, so any reference type object, if it's empty, if it doesn't contain a value, you've not given it a value, it's going to be null. So here I can just say here, I'll say say student dot say for example ID equals to say 90. Then I can also say student dot name equals to okay, let's use Rahul. And then student dot reg number equals to so let's print again and see it. And you can see we get the values, and we just, it's this method here, it's just like doing the print statements for us. Yeah, so there's a concept called encapsulation. So let's get the definition of encapsulation, but it's just like ideally bundling attributes and methods in a single entity or a class. So that's the definition of encapsulation. So we're bundling the attributes and methods in a class. So it's a core object-oriented programming that bundles data, that is variables, and methods that operate on that data into a single unit, typically what we refer to as a class. It's often referred to as data hiding because it prevents other classes from directly accessing or modifying the object's internal state. So for you to access specific things, like how we are doing here, we can access directly. We say student.id. So instead of doing this, we have a getter. We have what we call, okay, we have what we call getters to retrieve, and we have what we call setters. So for example, I wanted to print the name like that. So I'll just say print line like this, and then say this thing student, and then I say dot name. So that's like directly accessing the fields, which is ideally not correct. Which is ideally not correct. So as you can see, okay, I get Rahul as the name here. This is the name. So encapsulation, this is part of encapsulation, and then now we need to do this as private, and then this is private, then this also is private. Yeah. So as you can see, for some reason I can still access them. Yeah, I can still access them. I guess the reason being is because of where this class is at. So let me just, yeah, so it's accessible to these things here are accessible to that. So what I'll do is I'll take this because of package and whatnot, privacy. So I'll just come here, src here, create a new class, just call it student. That I'll pass the thing there, and then when I come to main now, you can see I don't have direct access to them. So it means that this is wrong. So what I need to do for me to assign the values is either use a constructor. This is how a constructor looks like. So the constructor is just like a special method, but it has the same name as the class. So I'll say public, and then student. So this is a constructor is what is normally used when you're creating an object. So I can just take here an int id. I need an id, and then I say string name like that, and then say string reg number like that, and then here we use this operator. So when you say this dot id, it's referring to this, the current instance. So this id. So we just take this id equals to this id. And sometimes you might have a different name for id here, so you possibly won't need to use this keyword. So for example, id like that, you can just say id st, and then it knows what you're referring to. This id would be, yeah. So yeah, I'll just revert to what I had initially. So it's not like compulsory for you to have the things similar. So this dot name again, and the registration number. So this is how we can create the values. So I can come here. So we already have an issue. So at first we have what we call the default constructor. So the default constructor is just like an empty constructor. So if you don't provide a constructor, this is under the hood what Java is doing for you. So it's creating the default constructor. So this is how the default constructor would look like. So we just say public student like that, and then it doesn't have anything. So that is the default constructor. You can also be creative. You can do constructor chaining and whatnot, but remember, if you don't provide any constructor, Java creates the default for you. But if you create a constructor, the default constructor created by Java disappears. So if you want to have the luxury of not having to pass fields in your constructor, you'll need to create it yourself. So you'll need to do that. You can also do this. You can say this and then pass these values here. So like this is a default name, then this is a default reg. So what this is doing is it's calling this. Okay, when you say this and then pass all these things, it's referring to this constructor here. So it will pass the default values. The default value for id is 0. The default name is that and that. So if I come here, the error is gone. This one I can't access it directly. If I run this method, you can see you get the values: default name, default reg, and whatnot. Okay. But now if I pass the values here, like the id is 90, the name is Ian, and then this other piece, the registration number. So thanks for that. So you can see the constructor that will be called is the constructor that we created initially that contains those. So and yeah, so that's ideally the concept of object classes and some encapsulation there. So if you look at this one here, how to implement, so you declare classes and variables as private. So this ensures that data is hidden from direct access by external classes, and then you provide a public getter and set methods. So we need them. So we need set and getters. So how a setter would look like for this student. So if I come here, so this is where we have getter. So we have id. So you need every field needs to have their getter. So public, it returns an int. Just say get id like that, and then it would look something like this, and then return id. So it refers to the thing that has been created there. I'll create another one for string name. Just say get name. Oh boy, yeah, get name like that, and then you just return the name. We also have what we call setters. So in case you don't want to use constructor to assign the values, you can use a setter. So a setter is just like acting but for a specific field. So it's a void. Normally they are void methods. So void are methods that we don't expect a return type. And then this is a method that has a return type. So it means that whatever this method returns can be assigned or can be stored in another container or variable. So void set, for example, ID. And then so for this, I'll need an ID like that. And then here, I'll just say this dot ID equals to whatever ID is passed here. So this is just stealing from what the constructor is doing. The constructor can set more, but now this for set ID, we're just setting the ID. The same applies to, say, for example, the name, public string set name, like that. We can have string name, like that, and then say this dot name equals to name. So this is just doing the same thing here. So constructor can take even more. So we can, so what do we have? Should be void. So we can come here. So we've set the name, we can modify them. So we just say student dot set the ID. I just change it to, for example, something like 100. So if I print it, you can see that the ID is 100, even though in the constructor I passed 90. So this setup looks like this. Okie dokie. I'm trying to look at what we can kind of cover next. So is inheritance. So inheritance is quite easy. So I'll just use this here to perform inheritance. So inheritance is where you have class A and class B, and then class B can have access to method, also attributes, I guess, for this. So let's see what inheritance. So OOP allows one class, the subclass, to acquire the properties and behaviors or fields and methods of another class, which is a superclass. So A is going to be the superclass, B is going to be the child class. So the thing that you need to understand is the parent is called the superclass is called the parent of the base class. So the existing class where the features are inherited from. Subclass is also known as child or derived. So this is the one that is inheriting stuff from the superclass. And then the keyword that you need to understand here is extend. So it is the one that shows that, okay, B is trying to inherit things from A. And then the super keyword, so this is used within a subclass to refer to the immediate parent class. So the constructor, when you're making a call to the constructor of the superclass. So in Java, we have the single inheritance. So A and B, a subclass and a superclass, only one. Multi-level is a class inherits from a subclass and then it creates a chain. So C inherits from B and then B inherits from A. So A, B, C. So there's that hierarchy. So that is multi-level. Okay. Yeah, that's multi-level. And then hierarchical is when you have two classes that are inheriting from the same class. So like similar just to how the family structure looks like. Multiple inheritance. So this is not possible in Java because there is a confusion. The compiler would be confused which. So this means that you have one class and then it's trying to extend from two classes. So that's multiple inheritance is not possible. So for you to kind of have that quote unquote behavior, so you achieve it via the interface, because with interfaces you can always implement multiple interfaces. And then hybrid, a combination of two or more types. I don't know how this is done, but yeah, we'll get to see it. So the classic example that is given, so I'll just create the class called okay, I'll just create the class called animal, like that. It has those fields, name and age. I'm not using encapsulation here, so you have to forgive me for that. I'll create a method called void, called eat, and then it's supposed to print something like eating. So, and then I can also create another class here, call it a dog, and then say extends, and then I can say it extends animal. Like that. And then I can now do a bunch of things here. So I can add, so here we had two fields, name and age. So a dog can have name and age, and then we can also have the age like that. So I have additional fields. So this is how inheritance happens. So I can have access to the methods that I've declared here, eat, but now it will have a new implementation. And that is what we call overriding, method overriding. So you're extending, you want to call the method that existed above, but now you're having your own new implementation. So we have this keyword called override, override like that, and then just say public, and then the method is void, so just say void. The method name is called it like that, and you can see it works. And then I just print line here, print line, and then say it's eating. Dog is eating. So, and you can see you can extend. So a dog would have these two properties, name and age. Of course, you can have them as private and then have the getters for them, but I'm trying to do away with the need for getters. Then you have this, or let's just use encapsulation because we've already. So let's say here. Then here you can just say alt. I can generate the getters and setter. Yeah, I can do the generation there. So I'll just say here private, and then I can also generate them. So, but how does it access those fields? So how it accesses them is through the constructor. So we'll just create the constructor for this. It's a dog, and then we can pass in the breed, string breed like that. And then, so how I can access those fields is I just say super, and then the super constructor. So I need to have a super constructor here. This is the constructor for this. So I can also generate the constructor for this. So by now you should know what a constructor is all about. Okay, that's the constructor I've generated for that. So when I come here to super, I need to pass two things. I need to pass, as you can see, if I hover here, expected two arguments, but found none. So I need to pass two things. I need to pass string name and age. So I'll just say name and age like that, and then here I can come say string name and age. So that's how inheritance looks like. So if I come here, create an animal, I'll create two things. I'll say animal. I need an animal, and then for this I just need two things. So I'll just create a generic animal like that, and then the age is that, and then I can do animal dot it like that. So this one is going to access the method from animal. At the same time, I can now create a dog. So for dog, I don't need to specify that it's a dog. Just say animal dog like this equals to. So the object that is created is now dog like that, and then call the constructor. So the constructor accepts these three things. The name is a dog, age is 2, and then it's a bulldog. So here I can say a dog.hit. So for me to ensure that it's flexible, I'll just take here in the print, I'll just say name plus eating so that we see the difference here. I'll also say get name. So that one we get the name of. So let's see what we get. Oh boy, oh boy. Yeah, so we have a dog is eating and animal is eating. So that's ideally inheritance. So there are a bunch of things you can do with inheritance, but that's what I have. Polymorphism, we've already seen one type of polymorphism. So ideally polymorphism, poly means many, morph, just like one thing appearing in many forms. So the example I normally give is right now I act as a creator. At home I am a son. At school I was a student. So it's just one Ian, but depending on where he is, he's playing different roles. Okay, so the same applies to this. So we have the method called it in the animal class. So this is the method called it. In the animal class, it's saying that name of that class. Okay, it's a whatever name you pass there, and then it. If it comes to dog, it would say dog it something. So The classic or more practical example would be something like what? Let's say inheritance or polymorphism. Something like save file, for example. Save file, you can be having like multiple ways of saving files. So if you're on development environment, you're saving your files in your local machine. So if it's in production, you're saving them on AWS or Azure. So that's a classic example to show you how polymorphism would find application for this case. So there are two types of polymorphism. We have runtime polymorphism and we also have compile time polymorphism. So from the name, you get what they mean. There's you can go in depth, learn about I don't know method dispatch and whatnot, but for the surface level runtime happens during runtime, so it's called overriding. So runtime overriding, so method overriding, like what we've seen. So here, this method, when we call the it method, so it would be determined at runtime based on the object that is created. Like for this case, the object that is created is dog. Sorry, and then the object that is created here is an animal. So that's the thing. We also have method overloading. So method overloading is compile time. So if, for example, we had a method here, uh, this is the classic example that is normally given. Void add, and then we say int a into b, like that. So this is not possible. Yeah, that is mad. Yeah, int a and b, and then here it should actually be void. You just return an int, and then here I just say, yeah, here I just say return a plus b. So it's add method, but it's taking two integers. So we can also have the same int add, but it's now taking 3. So return that. So it takes 3. We can also have int add like that, but it's taking different types. So double a, then double b. So for this case, we'll have to cast. We have to do what we call type casting. The result, or we can change this into a double. So that's still, but this is called a compile time or method overloading. So you get the concept. Overload, you overload a method. So you overload the method by changing the parameters or adding more parameters to the pre-existing methods. And yeah, that's polymorphism. This is method overloading or compile time. And then the other one that we see, it normally overriding happens just in inheritance or when you have interfaces, whatnot. That's where. Okay, that's polymorphism. Okay, now the next bit is abstraction. So abstraction is like a very nice. So you're trying to hide the inner implementations of whatnot of your classes, yeah, abstraction. So you don't want the logic to be seen. So here is a principle focused on hiding the internal implementation details of a system and showing only its essential functionality to the user. So you have a car, and you don't want, you as a driver, you don't want the driver to care about how, if I steer on the left, how is the engine, how are the pistons moving and whatnot. So you abstract that by providing a steering wheel, and then theirs is just to move, and then they have the gas pedals and whatnot to do the thing. So here it allows you to focus on what an object does rather than how it does it. So you don't care about the pistons. So yeah, that is not in your interest. So ways to achieve it is Java provides two primary tools to implement abstraction. So we have abstract classes, 0 to 100% abstraction. A class declared with abstract keyword that cannot be instantiated directly. So we'll talk about this one. And then you also have interfaces, which is like 100% abstraction. So you just create a blueprint of a class that usually contains only abstract methods, so methods without implementation. And then, okay, Java 8 introduced default methods and static methods as well, but that is the idea of interfaces. So it's just like a contract that other classes that implement it should always do a bunch of things. So an example is this. So I'll just come back to this, what we have here. So this is an interface. So let's start with the interface. Interface. let me just say user service like that. And then you have a method called save user. So abstract method are methods without implementations, so they don't have a body. And then say this is a void, for example, void save user. Okay, so you might have this interface. You have now, you can create a class like this, then say call it user service implementation, and then say implements. I need to type it so that you get implements, and then into implements that interface user service, and then you will get a compile time error. It's telling us that we need to override the method. So this is method overriding. Okay, so how we do that is we have the annotation at override like that, and then the method is a void, so we just say public void save user like that, and then here we can just do something. Let's just say void not void, user saved, something of the sort. So this is providing a skeleton here, and then the implementation is the one that is doing the thing, the actual implementation. So if I come here to our entry point, I'll just say here, I'll just use the service interface, and then say user service like that equals to new user service implementation, and then I can now do the user service dot save user like that. That's the idea behind interfaces. So you just provide a bunch of methods, and then you'll be using the interface to do a bunch of things. So for it to make sense is when you're doing what we call dependency injection. So you normally don't inject the implementation. You can use the interface, so that the caller doesn't have to really know how this specific method is implemented. So it just calls via the interfaces, and then there's a concept of proxy. There's a proxy that is created, and then it is used to call the method for you, but you shouldn't worry about it. So this is how an interface ideally the simplest would look like. So you can add a default say something like a print user, could be void like this, and then this one can now have like the body. So default, I don't know if you can have two defaults, I'm not really sure. Yeah, you can't. Okay, possibly the name. Yeah, you can have default, but I'm not sure why you'd have a default. But default methods, it's not a must for you to implement them. That's the catch with default methods. It's not a must for you to implement, because if I remove this, you'd see I get an error here. Okay, there's for this, but the main thing here is I need to implement. It tells me that I need to implement. So with default methods, you don't have to. So this is trying to ensure that there's some flexibility. So if you have a bunch of classes that are implementing, so I can have another interface here just to show you the concept of multiple inheritance. I can just say file service like that, and then here something. This is very, very unrelated, but you can do this. You can do a comma, and then you can say file service like that. So if you want to save something, like you have to if you want to save the user in a file, so you need to do this. But yeah, this is very, very bad example to show you can do it, but yeah, there's a possibility of you doing, so you can override that. Yeah, that's it for interfaces. Yeah, but there's a lot you need to look at when it comes to interfaces. So one, you need to understand these differences that have been given here. Is the characteristics is they had complexity, like a TV remote where you press a button and then without the needing to understand the internal circuitry. Abstract methods, they are declared without a body and must be implemented by an abstract class. Very important. And then non-instantiation, you can not create an object of an abstract class using the new keyword. It's a class, yes, but it's just defining a base of how your other classes that extend. So for abstract classes, you extend, so it's just defining how things would look like. And then you can choose a new keyword there. And then for inheritance, you use an abstract class. You must inherit from another class and provide implementation for its abstract methods. So normal inheritance, where you inherit from a class, you don't have to override the methods and whatnot. But for an abstract class that is acting as a superclass, you must always do the thing. So let me just show you how an abstract class would, say for example, work. So we can say abstract class user, for example. Let me just say base user. Let me just say user, like that. And then for an abstract class, it must always have an abstract method. So you just say abstract, no, abstract void save user, like that. It must always have that. And then you can have fields. You can have fields. String name, like that. And then you can have a method with an implementation, void print user, then you can just click user printed. And then now you can have a type of a user. Okay, so you can have it as a class, and then this is somebody like employee. No, say admin is a user, but it's a different type of a user, so it can extend. We just say extends and then user, like that. And then you see, if I do that, it means I need to implement the method. So I need to implement that abstract method. So yeah, I need to implement. So here I can just say print line and then say admin save. Just with normal inheritance, you can access the other fields as well. You can access the fields. Ideally, that's the general idea of abstract classes. So an abstract class can have both abstract and non-abstract method. The interface, it's traditionally only abstract. So modern versions allow default and static methods, which we've seen the default methods. So variables, here we just say that they can have final and non-final, static and non-static variables. So that is for an abstract class. And then variables are public, static, and final by default. And then inheritance can only extend one abstract class, and then for interface you can implement a bunch of interfaces. Constructor can have constructors, this other one cannot have constructors. So an abstract class is just like it's defining like the base class for other classes, just like a super class, any other super class. But here we just like you can have abstract methods. So abstract methods, you have to have the abstract keyword and whatnot. Yeah, yeah. So that's the whole idea of the major things you kind of need to know in Java, abstract classes and what. So I wanted the video to be 10 minutes. It ended up being an hour, almost an hour, but I hope you had fun. I'll possibly record a cleaner version where we talk about things step by step in Java. And yeah, we just like have fun learning. So thank you so much for watching up to this very point. Ian Duncan is my name, a software engineer and instructor at Amigos Code. You can check out the academy. I'll share the link. But yeah, thank you so much for watching up to this very end. I hope you enjoy the rest of your day. Cheers.